Hello guys, thanks for joining this session. In this session, we are going to discuss about another VPC component, that is NAT gateways and NAT instances. In short, we are going to discuss about NAT, that is network address translation. So let's jump into the diagram. So now we are into this diagram. We have already discussed about subnets, route table, internet gateway. In last session we have discussed about elastic IP. Now we will discuss about NAT, and we will discuss about NAT gateways along with NAT instance. So majorly we are going to discuss about NAT gateways, but prior to discussing about NAT gateway versus NAT instance, we should understand that what actually NAT is. So NAT stands for network address translation. So here the question comes is, why do we use NAT? So to answer the question, we use NAT to enable instances in a private subnet to connect to the internet. So you must be wondering that why should I connect private instances to the internet? And if you wanted to connect to the internet, why do I created the instance as private instance? So to answer your question, in certain scenarios where we must have to keep our instance as private, because some kind of application like databases must reside into the private instances, and we want to connect the private instance to the internet because of software update within private instances, so that only private instance can access the internet, but internet can't have direct access to the private instances. So to achieve this, we need a mechanism which will take care of this complex scenario, and the mechanism is NAT, network address translation. So now let's discuss about how NAT basically works. A NAT device forward traffic from the instances in the private subnet to the internet or other AWS services, and then sends the response back to the instances. When traffic goes to the internet, the source IPv4 address is replaced with the NAT device address, and similarly when the response traffic goes to those instances, the NAT devices translate the address back to those instances' private IPv4 addresses. Now we understand that how it works. We will move further and we will discuss about some of the points to remember. NAT devices are not supported for IPv6 traffic. We can implement NAT design within our AWS infrastructure by two ways. Either we can opt the NAT gateway services from AWS, or we can create a NAT EC2 instance using NAT AMIs provided by AWS. So here question comes is, which is the best way or say recommended way for NAT management? So the recommendation from AWS is to use NAT gateways. Why? Because first of all, NAT gateways is a managed service. So the benefit of managed service is we don't need to give the administration effort. Now move further, we will look into one of the architectural diagram and discuss some of the important points. So this is our NAT gateway setup. If you will look into that, then you will find that within AWS we have a setup of VPC, and that contains two of the subnet. One is the public subnet, another one is the private subnet. And here you will find that within the public subnet there are three EC2 instances is running with the following elastic IPs, and it has NAT gateway associated with. And within the private subnet you will find that there is a database server is running, three database instances of the server is running, and there is a implied router is also being applied to do the communication with the public subnet web servers. So here you will find that if you look into that, it is going through implied router, and here it is going to the NAT gateways, and then the communication is happening over here. And here you will find that the entry for NAT gateway is done in main root table and also within the custom root table. So as we discussed that, suppose that if we want to do any kind of a patch or say software update process, want to run the software update process, then we need to access the internet to download the software and run the patch into this database server. So this is not a feasible solution to expose this private subnet as public subnet, as it is a risk for the business. So NAT gateway help us in this situation. Now discuss some of the important points to remember about NAT gateway. The point is, to create a NAT gateway we must specify the public subnet in which NAT gateway should reside. We must also specify an elastic IP address to associate with the NAT gateway when we create it. One point you should remember that the elastic IP address cannot be changed once we associated it with a NAT gateway. Another point related to the configuration. Once we have created the NAT gateway, then we must have to update the route table associated with one or more of our private subnet to point internet bound traffic to the NAT gateway. This step is really very important, as this step enables instances in our private subnet to communicate with the internet. So these are some of the point, or say good points for NAT gateway. So now the question come over here is there any limitations of NAT gateway? Then I can say that yes, there are certain limitations. We will discuss that limitations now. A NAT gateway supports 5 Gbps of bandwidth and automatically scales up to 45 Gbps. We cannot associate a security group with a NAT gateway. We can use security groups for our instances in the private subnet to control the traffic to and from those instances. We can use a NACL or say network ACL to control the traffic to and from the subnet in which NAT gateway is located. Now we understand this, we will proceed further and discuss some comparison between NAT gateway and NAT instances. So the first aspect of comparison is availability. If we talk about NAT gateway, then NAT gateway is highly available as it is a managed service. So NAT gateways in each availability zone are implemented with redundancy. We should create a NAT gateway in each availability zone to ensure zone independent architecture. On the other hand, for NAT instances, in terms of availability, we need to use a script to manage failover between instances. Now moving to the another point of comparison is bandwidth. In the bandwidth aspect, NAT gateways can scale up to 45 Gbps, and on the other hand, NAT instances bandwidth can be depends upon the instance type. Now moving further, another point of comparison is maintenance. Maintenance wise, with NAT gateway you don't have to bother about maintenance as it is a managed service. All the maintenance thing, administrative task is taken care by AWS, and if we talk about NAT instances, then it should be managed by us only. Any kind of patchwork like software update, operating system patches on the instances where NAT instance is running, is all these things are taken care by us only. So these are some of the major point of comparison which I wanted to discuss with you regarding NAT gateway versus NAT instance. So that's it guys, this is what I wanted to discuss with you in this session. See you in the next session. Till then, bye bye, take care.